34, yeah.
So like halfway then, yeah. Oh, we're over halfway.
Okay, hello. Guys, we might get started because it is after 10 o'clock. We've got obviously this set up in terms of with the microphone and whatever. I know there's only a small number of you here now, but hopefully you'll be able to hear and see things fairly clearly. So first thing is, thank you so much for being here. I appreciate this is your first week of holidays and you've decided to come and spend 2 hours on a Thursday doing some maths. So we do really appreciate that, and we like the fact that it does show that you are keen to get some extra help for your external exam. So a lot of you have been asking me about how the mocks have gone. We haven't started marking those yet, and to be honest, the mock is just a tool or a revision tool really for the external. So we're not really concerned whether you all go really well or really badly or anything in between, because that'll be something that you can use to revise for the external. The end game, of course, is this external exam on the 1st and 2nd of November. So that's what we're preparing for. In terms of what we've decided to do today, so Mrs Simpson and myself have spent some time planning this. And look, there's lots of things that we could have done because obviously there's a lot of work to revise for this exam. So we decided to base it on the formula sheet. So one of the things with the exam is that you know that it covers content from Unit 3 and 4 with assumed knowledge of content from Unit 1 and 2, but also every formula on the formula sheet is up for grabs. So any formula in here could be in the exam and examined. So the way we've set out the booklet is that we have picked, questions that relate to some of the formulas from the formula sheet. We haven't done all of them. So certainly that first section on measurement, for example, we've only really focused on the earth geometry from there. But we've done a bit on the finance, the sequences, and then some of the other things as well. So that's what the booklet, that's what we've decided to do. In terms of where we've got the questions from, so we've had a look at the external exam from last year, the mock exam from last year, and the mock exam that you've just done. So that's the 3 most recent exams covering Unit 3 and 4, and we've just taken example questions from those 3 exams that relate to the formulas in the formula booklet. So today we will go through some of the questions that you did do in the mock, so you'll get to see how you went with those. But that's what we've based it on, and you'll be able to see too that some of the questions that keep coming up. So there are certainly some questions that have come up in all 3 of those exams, and you'll start to get a bit of an idea where you'll find those questions. All right, so in terms of what we're going to do, we are going to use the 2 hours. So if you do need to duck out to use the bathroom at all during the session, quite okay for you to do that. Just kind of hop up and quietly slip out. You don't need to ask us if you want to do that. We might have a little bit of a stand up and stretch break halfway through, but we figure you've come here for the 2 hours. It's going to be 2 hours of maths, which is very exciting. All right, so we're not going to go through it. It's a 33-page document. I know, it's exciting. And look, we won't get time to go through all of those questions today, so there are some that we'll go through. You'll be able to see that on the screen, and we would ask that you would then be copying solutions down as we go. After the session later this afternoon, we've done the worked solutions for all of these questions, and we put some extra notes and highlighting and things in there, so you will then have access to that booklet as well. And I'll email you all to let you know when that's in the drive. All right. Just if you can then, on your booklet, on that front page, we spent a bit of time thinking just some general tips for this exam. The exam's coming up. So in terms of the details on the front there, you can see on the screen as well, you know that you're doing the 2 papers like you did recently, the simple and the complex. They are both 90 minutes and they're 5 minutes perusal in each of them as per the mock exams, and you will have 15 multiple choice questions in that simple familiar paper. Can we suggest do not spend more than 20 minutes on those 15 questions? they can take up time, and you don't want to waste time on those multiple choice questions. So with your timing in the hour and a half, think of 20 minutes only on those multiple choice questions. Just with some of the general tips, without reading through all of them point by point, because I'm going to hope and assume you'll read through them, just to summarise some of those, in terms of your working, remember an external marker is marking this exam. So up until this point, we've marked the exams for you, and we can kind of, guess or have a bit of a stab at what you were trying to, write down. And particularly if we teach you, that's easier for us to do. But remember, external random people are marking this, and different people are marking your exams. It's not the one person marking everyone's. There's a lot of different people. So you've got to help them out. You've got to actually be really clear with what you're doing with your working and really help them out by explaining what you have done. Okay? Anything you type into the calculator needs to be written on your page. So even if it's 5 plus 3, that's got to be written down. Right? Anything you write in. Multiple choice, there's a few tips there. You will need a 2B pencil on the day, and you've got to colour in the little oval completely. It is marked by a computer. So just keep that in mind. And if you need to change an answer, you've got to erase it, make sure it's completely erased, your previous answer. Otherwise, it comes across on the computer as 2 answers and it won't be marked. So just be mindful of that. Any formulas that you use, so anything you've chosen from your formula booklet, or if it's a formula that's not in the booklet that you need to remember, make sure you write it down as part of your solution, because sometimes the formula itself will be worth marks. Sometimes it won't be, but sometimes it will be. So always write down that formula. You don't want to try and skip out any steps. There's some information we've put in there about perusal. Perusal is valuable time to make sure you do read through all the questions. And I would then take a minute or two once the time starts to write on this formula book. And I would be writing down any extra notes that you need, going through and saying, which formula relates to which question, just to remind yourself so that when you get to particularly towards the end of the exam, that you've made a note to yourself earlier so that you don't forget that. Things with definitions. So things like, if you've got to think, particularly all the network stuff, the Hungarian algorithms, the Euler trails, the Hamiltonian, the minimum spanning trees, the walks, the paths, all of those things, they are definitions that you have to know. You've got to know the difference between all of those things. And if you have to think to yourself in that moment, what's a Hamiltonian path again? Then write it down. So if you're thinking that in your head, write down notes. If you're thinking, what's a minimum spanning tree? Actually write down what that is on the page. That could be worth marks. So just make sure you write that down. As Ms. Scott mentioned in the mock exam and the instructions, the amount of space that's given to you in the exam is an indication of how big your answer should be. Not so much today. We probably haven't really given you enough space with some of the answers for today, but certainly in the exam that would be an indication of how much working you would need to have. So just judge that on the number of lines or space. Rounding, be careful. And remember, for financial maths, money is rounded to 2 decimal places. You will lose marks if you have more than 2 decimal places in a money answer. There's lots of little ways we want to make sure that you are getting as many marks as possible. A couple of other things which we may not have mentioned. You can't use erasable pens in the external, so if you do use those, don't bring those with you. And then at the end, I'll talk about this at the end of the session about doing practice exam papers. So that's, from now on, that is really your best revision that you can be doing, is practice exam papers. And we've got, I think, about 4 of them in the drive at the moment, and I'll be adding a lot more this afternoon as well. Okay, so that's the front page. Take some time to read that yourself in the coming weeks as well. Are we ready to go? Resounding yes, very good. All right, so turn over. We are going to start with the first question. All right, so again, obviously all of you are at different stages with your revision, so some of you will be able to whip through some of these questions. Some of you may not have actually started revision at all, and that's okay. So we're going to just talk through the answers. I'll be writing it on the screen. You'll be able to copy it down as you go. If you look at something and you want to work ahead yourself, that's completely up to you. Okay? As I said, we won't get time to go through all of them, but that will leave you with some other questions for you to try in your own time. Okay? All right, so from that measurement section of the formula sheet, what we're focusing on is the earth geometry section, and there are those two formulas there for calculating distance. So one of them relates to two places that are on the same line of longitude or both on the equator. So the equator, you might remember, is a great circle. The lines of longitude are half great circles. So anything that's on those bigger circles, this is the formula we're using, and you need to know the difference between this one and the cos one. All right, so for this one, this has come from your exam that you've just done, so from your mock exam from last week. All right, so work out the distance to the nearest kilometre. So if you are someone who highlights, I'm someone who highlights, I would actually, let's see how we go, I'd be highlighting nearest kilometre. So that would remind me that my answer has to be to that unit, and you will lose marks if you don't put it to the nearest kilometre, which can be very frustrating if it's a correct answer, but you haven't actually followed that instruction. All right, so meridian of longitude, so that would be the next thing, because that would indicate to me that I'm about to choose the formula that's written above there. And we've got Port Douglas and Pakenham. So you might also want to, you've got to look for the two measurements that are the same, and they are on the same line of longitude. So that is what has made you decide to use this formula. So 111.2 times by the angular distance. And you would write that down as part of your solution. That could be worth marks, just to write down the correct formula. All right, we need to work out the angular distance. So angular distance. Ooh. All right. And we have to, you can see that in terms of the latitudes, they're both south. So that means we're going to subtract. Remember, if one of them was south and one of them was north, we would add those two angles together. But because they're both south of the equator, we're going to do 38 degrees and 4 minutes minus 16 degrees and 29 minutes. Now, on your calculator, do we remember where the degrees, minutes, seconds button is? So it's that one that's got the little dot with the little commas. It's above the ENG on this calculator, above the ENG button. So second row, above where the all clear and all that sort of stuff is. So the little degrees with the little commas. And what we found is that certainly in the mock exams and the externals, the angles tend to be given in degrees and minutes. All right, so you just need to remember how to type them in. When you type that in, hopefully you'll get 21 degrees and 35 minutes. Okay, so you might have time to check that. So that's our angular distance. Now we just need to put that into the formula, times 21 degrees 35, and that will give you an answer. Now you would actually write out the answer with the decimals for that. So I got 2440.1. Just check if you got that. But remember, we had highlighted our instruction, which was to the nearest kilometre. So we therefore need to go 2,400, and that's our answer to the nearest kilometre. All right. Another thing with the mocks and the externals, certainly, no half marks are given. So it's only full marks. This question in the mock exam was out of 2 marks, and there was a mark to get that and a mark for that. So even if you hadn't rounded to the nearest kilometre, if you'd left it as 2,400.1, you get nothing. All right, so you've got to make sure you read those instructions. Okay. Can I turn the page? I get very excited, and you might have to tell me when to, if I'm getting too thrilled with it all. All right. Okay, the other formula is the one with the cos in it. And this is for places that are on the same line of latitude, so on the same small circle. So that first value, which is your latitude, will be exactly the same. And again, of course, you have to recognise that in the question. All right, in terms of highlighting, so we're still calculating the distance. Important things here, parallel of latitude. So latitude is the cos. So that's made you select the cos formula. You might then go, okay, those two bits are the same. So we've realised they're on the same latitude. And again, we've got nearest kilometre. Okay, and that's something that comes up quite a bit. All right, so in doing that, you would probably start with your formula. I didn't leave you much room there. Times by the angular distance. And again, that could be worth a mark. We need to work out that angular distance. So angular distance. All right, so looking at our longitudes, they're both east. So if one had been east and one had been west, if they're on different sides, we'd need to add them. But because they're on the same side, we're subtracting. So 147.37 minus 140.47. And again, you'll put that into your calculator with your degrees, minutes and seconds button. And hopefully you'll get 6 degrees and 50. Didn't leave you much room, did I apologise for that? All right, so our distance, 111.2, the angle that goes with the cos is the latitude angle. So that 37 degrees and 50 is what goes after the cos. Then we've got our 6 degrees 50 that we've just found. Type that in. And I think that's what I got, so 600.14. So again, write down with the decimal. It's got to be to the nearest kilometre. Oh, so that's now going to be 600. Okay, so working very similar to the one before. From a marking point of view, so this is actually from the external exam from last year. So this is one of the ones in the simple familiar paper, and that was worth 3 marks. One of the marks was for finding the angular distance, second mark for subbing into the formula, and then that third mark for getting the correct answer. All right, I have actually put the marking scheme into the work solution. So when you have a look at that when it's in the drive, you'll see where marks were allocated for various questions, and so that just might help you with what you do with your working. Okay, there is another question down the bottom of that page which we'll leave for you to do in your own time. So, sorry, I'll leave that there for a minute. We're going to turn over to the finance section. We'll start with that.
Can I bring this down? Oh, sorry. Sorry, guys. I'll give you another couple seconds and then we'll move on. Okay, are we good to go, guys? All right. So if we can please flip over to the financial maths, and we're going to start with simple interest. Yes, this is something that you guys did in year 11, but we have to assume that you know this knowledge, and these questions were in the mocks from last year and the mocks from this year. So it's definitely something you still need to know. Okay, so first question. We have 2 options. Mark's investing some money and he's got 2 options, and we need to calculate the value of both of the options. So when we're reading through here, firstly, we're just going to identify that we are investing $28,000 and we're investing for 2 years. So if we are having a look, and if you have a look in the right-hand corner up here, we've told you what everything means in the formula, which hopefully you guys already know. So I just want to make sure that I know the information I have to put in. If I look at option 1, it says we need to use simple interest at 8.5% per annum, and option 2 is 8.5% per annum compounding. So if we're just doing the simple interest, we're only doing option 1. The compounding can wait for the other formula. All right, so in that option 1 information, it tells us that we are investing at 8.5% per annum, and I'm also going to highlight that as well. The other important thing that you need to remember that isn't written on a formula sheet is we are calculating the value of the investment. So we need to find the interest, and then we're going to add interest and principal together. And that's something that a lot of people forget to do. All right, so if we write out our formula, that's our first step. We've got all of our information already highlighted, so we're going to throw it straight in. But I just want to remind you, when we've got our formula, our interest rate here, we need to make sure that we divide it by 100. So we're going to do 8.5 over 100, which hopefully we can all just do in our heads. And that's the number we're going to use in our calculation. So let's throw in our substitution. And we're investing for 2 years. You should then get a value of 4,760. That's only the first part, and doing all of that is worth 1 mark. The next part, the value part, was where we're finding the total amount. So we're adding our principal plus our interest. So we started with 28,000. We're adding our 4,760. So our total value is going to be 32,760. So I'm just going to pop on there for you where the marks go. All right. Guys, we're not going to do the question at the bottom of the page, but if you have a look at the question at the bottom, it's doing the option 2. This is a really common question where you have to do a simple interest and a compound interest and then compare and say which one's the better investment. But we're going to leave that one and go to the next page, please. So this was in your paper that you just sat. And it is a compound interest question. All right, so loans are offered by lender A at a rate of, and I'm going to start highlighting from here, 13.2% per annum, compounding monthly. Lender B, I'm just going to put in a different colour, was at a rate of 13.9% and we're compounding annually. So our question, 27,500 is borrowed from lender A and the principal and interest repaid after a period of 3 years. Calculate the amount to be repaid. So I'm also going to highlight calculate the amount to be repaid. Okay, what you need to remember when you're doing this question is when we do compound interest, it automatically calculates the total amount. So there's no adding that we need to do at the end. So the first thing we're going to do is write our formula down. This is sometimes where people get caught out and they do too many dividing steps. It's certainly something that happened in my class, in our practices, and I know it happened across the board. So it's something that we need to remember. Okay, so I'm just going to do one more highlight. Sorry, guys, just going to highlight the principal. So P is the principal, 27,500. Okay, for our interest rate, I'm just going to do this off to the side for a second. Apologies. Okay, so with our interest rate, we've got 13.2 over 100. So we know that we're going to have 0.132. You can do this step now and then substitute it in, or you can just put the fraction into your calculation. So to get your interest rate, you need to do 0.132 over 12 because we're compounding monthly. You can do that and find your decimal and that's fine, or you can just grab that fraction and throw it straight in. Just be careful when you do fractions like this because if it is not a terminating decimal and if you have to round it, you might not get a precise answer. So if it's not precise, it's best to put in the fraction as that. And for our n, we need to remember when we do compound interest that the n is talking about the number of compounding periods, not just the number of years. So similar to what we have to do with annuities as well. So we are doing this investment for 3 years and we're compounding monthly. So it's going to be to the power of 3 times 12. Once you plug that in, you will get an answer of $40,773.15. Please make sure when you do this and you get your answer, you round to 2 decimal places. Otherwise, you won't get the mark. If you round it to 2 decimal places and you round it incorrectly, you will not get the mark either. So it needs to be rounded to 2 decimal places and it needs to be rounded correctly. So there was 1 mark for your answer and 1 mark for all of your correct substitution into your formula. Cool. Okay, now we're going to move on to effective interest rate. No, because I've done something wrong here. No. Okay, so can we please go to, so the next page we start with effective. We're not going to do the first example. All of them are very, very similar. We're going to do this one from the mock last year. So we've got 2 effective interest rates to find, and then we're going to explain why one investment is better than the other. Is everyone ready? Cool. All right, so we need to do effective interest rate for both. The formula was on the last page, so I'm just going to go straight into part A. We have 4.28% per annum, and we're compounding daily. All right, so our effective interest rate, we're going to write our formula down. This is another one where we make really easy mistakes. All right, so with the info that we've got here, we're going to put it straight in. So 1 plus our interest rate is we're just doing our 4.28 over 100, so 0.0428. Over our n, we're going daily, so our n is 365. Close our bracket to the power of 365. Take away 1. Okay. We chose to do this question specifically because the answer for the effective interest rates are really, really close. So for this example, we would encourage that you perhaps go more than 2 decimal places. Perhaps like 4 or 5 would be better. So we have done that. We're going to get 0.043727, which will give us 4.373%. So remember when you get your answer to multiply by 100 so you get your percentage. Because some people didn't do that and it doesn't allow you to compare properly. Okay, so for part B, we are looking at 4.3% per annum and we're compounding quarterly. So if we're compounding quarterly, that means it's happening 4 times a year. So we write out our formula again. I know you guys love writing out formulas repetitively. Okay, and then we're going to sub in our information. So we've got 0.043 over 4 because we're compounding quarterly to the power of 4. Take away 1, which will give us a very close decimal to last time. All right, so we can see how close the decimals are there. That's why it's so important with our rounding. And part C right up the top said, explain why one investment gives a greater return than the other. So if you just write which one gives a better return, you're not going to get the mark because you need to explain it. Okay, so for part C, we're going to say option 1 is the best deal. We're going to give it a bit of detail. So although the interest rate appears lower, it compounds more often. Earning interest on the interest more regularly. Done. Confusing with these. I'm like, what am I up to? Where am I going? 1 second. Oh, I didn't write where the marks were there. Anyway.
So is that?
So that's next, and that goes there.
Okay.
Does that make sense?
All right, I promise I'll talk a bit more slowly this time. Thank you. All right. Okay, so there's a couple of other questions there. Yeah, as Ms Simpson mentioned, effective interest rate was in all three of those exams. So that was one of those questions that we found in all three of them, and they were all the same type of question. Okay, so they might be something that we would hope would turn up in this next exam. All right, so turn to the page now. We've got our recurrence relations. And I think on the formula sheet, there are three different types. Yeah, so three different types of recurrence relations. So one's for reducing balance loans, one is for compound interest, and there's one for annuities. And it's working out which one we need to use. The word recurrence relation should come up in the question. So if you have to actually create something with a recurrence relation, usually it would tell you that. And we've just added a bit of a definition there at the top of the page. So a recurrence relation, sometimes it's called a recursive rule. So recursive rule and recurrence relation are the same thing. It's just a rule that explains how to get from one term to the next. So whatever if you from term 1 to term 2, then from term 2 to term 3, etc. It's not a rule that will give you an answer like 5 years down the track in one hit. It's the one where on your calculator we can put the rule in and just keep hitting the equals sign, and that keeps giving us term after term as we go through. So that's what a recurrence relation actually is. When you hello, Dylan. Yeah, and look, this is where these are interesting. I'm not a fan of these relations, I'll be honest, because most of these questions, there's more than one way to do them. So this is a rule that we can use, but then pretty much for all of them, there's other rules that you can use. If you've got to create a mathematical model, so there were some questions in the mock where you had to do that. If it doesn't say create a recurrence model or a recursive model, I wouldn't do that. So that means you're pretty open. You can still, you've got that option, but you can use other models if you would like to. It's just that if the question does say to use a recurrence relation or a recursive rule, you have to do it then. All right. So look, we're going to go through some examples specifically using these formulas, just because they're part of your formula sheet, to show you when you would bring them up or when you would use them. So the first one is to do with reducing balance loans. All right, in terms of the formula, and again, we've got the information there on the side to tell you what those letters refer to. So you've got little r and big R. So little r is our rate, so it's our interest rate plus 1. So it's 100%, the 1 represents 100% plus the interest on top of that. So it's 1 plus I. And our big R is our loan repayment amount. So these are scenarios where we're paying off a loan and we're making maybe a regular monthly payment or something like that is coming out of the loan. All right, so this question is actually from the textbook. So it's from exercise 8A in the textbook. This is fairly lengthy, this answer, so I think we've given you another page. Yeah, so you've got a blank page after that because there's a fair bit to do with this question. All right, so Andrea needs to borrow $20,000. Her bank's going to charge interest at the annual percentage rate of 7.08. And let's start some highlighting. So we're compounding monthly. So that's going to be important information that we need. She's required to make monthly repayments of $600. So that's important. So automatically that's what big R is. So our capital R, that's our loan repayment amount. But Andrea thinks she can afford to pay $800 instead. Let's just do a different colour there because that's going to come into play as well. All right, so part A, construct a recurrence relation for the loan with monthly repayments of $600, and then we're going to apply it. So we've been told we have to do a recurrence relation. All right, so in terms of part A, we need to work out our little R value. So R is 1 plus I. So our I value, our interest rate was 7.08%. So we need to convert that. So our 7.08 over 100, so 0.0708. So we're going to put that in there straight away. And it's compounding monthly, so we need to divide that by 12. Okay, some of you I know, and I should have mentioned this before, some of you will do 7.08 over 100 times 12. I think there's a little formula somewhere in the textbook that says that. So if you are used to doing that, by all means keep doing that. Okay, I think when you type that in, I got 1.0059, which I think is a terminating decimal. If it was something that kept going on and you had to round off, you may need to keep that as the 1 plus the fraction. All right, for this we have our big R, which is our $600. So in terms of constructing our recurrence relation, when you create a recurrence relation, it has two parts. You've got to start with the starting amount, so A0, which was, I think, $20,000. And then you do the little rule. So RAN minus big R, so write out what the rule is. So we've got 1.0059 A to the N minus 600. So that is our recursive or recurrence relation for that particular model. All right, so we haven't even done part one yet. Righto, so part one, how much she would have after 5 months. So how much would Andrea have at 5 months? So we need to find A5 for this. All right, in terms of typing this into your calculator, so just to remind you, so you would type in the 20,000 and then hit equals. So if you're ready for that calculator, grab that. So 20,000 and then hit equals. So you go 20,000 equals, then you'll go times 1.0059 and then minus 600. And then we're going to hit equals 5 times. So we need the balance after 5 months. So you'll just have to make sure you count fairly carefully, hit equals 5 times, and the value you get then, hopefully, will be 17561.39. Okay, so that's what you would be typing into your calculator and then hit the equals button 5 times and you should get that total. Okay, so that's part one. That's how much she would owe after 5 months. So that's what the balance is. Should have highlighted that. Yep.
Just putting it like that next to the A5, is that good enough for working?
Yeah, it is. Yep. So that's the thing, in that kind of question, that would be worth 1 mark just to get that total. So there would have been marks allocated to create the recurrence relation, but in that part one, it literally would have just been the 1 mark, and you could just put the answer down. All right, in part two, we've got the total interest. Oh, okay, total interest that she would pay after 5 months. So this is a little bit more complicated. Now for this, I think there are some formulas in the textbook about this. But so I kind of do it a little bit differently without trying to remember an extra formula, because there's a lot of formulas on here. So we want to try and not have to remember too many extra formulas, I would think. So what I would do for this is to say, I've made loan repayments. She's made 5 repayments of $600. So she's paid $600 5 times. So that means she's actually paid $3,000 as part of her repayment. In that time, the reduction on her loan, so the loan reduction, we started with $20,000, and after 5 months we were at the $17,561.39, which means we've reduced by that much. So in that time, so remember with a loan, so she's actually physically paid the bank or the lending institution $3,000, but her loan has actually been reduced only by $2,438. So the interest is just the difference between those two. So 3,000 minus that. So 561.39. So that's how much the interest is. As I said, there is actually a formula in the textbook for that, and if you know that and you remembered that, fabulous. But that is another way that you can do it, which kind of just breaks it up into the 2 parts separately. All right, so if you have a look at Part B is pretty much exactly the same as the one we've just done. The only change is that we're now going to use the monthly repayment of $800 instead of the $600. Okay, so in terms of setting up the recurrence relation, the little r value is the same. It's just that the big R value becomes 800 instead of 600. Part 1, we still have to work out how much she owes after 5 months, and we've got to work out the total interest. It'll be exactly the same. So the working for Part B is exactly the same as Part A. It's just replacing the 600 with the 800. All right, so I'm going to leave you. You can do that working on your own. But moving on to Part C in that question, so if we go back to there, if she makes monthly repayments of 800 instead of the 600, how much interest will she save over the first 5 months? Okay, so you have calculated the interest for Part 2 in each of those parts, and that'll just be the difference between those interest amounts. Just to let you know, when you're checking your answer, for B Part 2, the interest was, what did I get, 549.52. So you'll be able to check that when you do your own working. And then in Part C, the savings will just be those two subtracted. 549, whoopsie, 0.52. And you'll have that answer. Okay, so rather than doing a repeated process in Part B, as I said, it's exactly the same as Part A. You'll just replace the 800 for the 600. In your answer for Part C, though, it's just subtracting those two interest amounts. With money and with all of your questions, make sure you're always putting units in for your answer. Sometimes in the marking schemes, it'll be worth 1 mark just for putting the units in there correctly. So always remember to do that as well. Okay. All right, so there's a couple of other questions relating to that from past papers, which we're going to leave you to do on your own. So there's one from the external from last year, one of the multiple choice questions. Remembering with multiple choice questions, in the booklet that you get for that, you can actually write in that booklet. So any working that you need to show for multiple, or you need to do for multiple choice questions, there's plenty of room in the little booklet for you to do that working. All right, moving on from there, the next recurrence relation is for compound interest. And of course, we have a compound interest formula. You've just done some questions using that, which can also be used for compound interest questions. So this is a formula you would use only if the question said to use a recurrence relation. If it didn't mention that, I would be using the normal compound interest formula, okay? We've put an example in there for you just to practice the use of that, but again, you can have a look at that yourself and when you can check that in the answers when I put them in the drive for you. All right, recurrence relation for annuities. The fun begins. Okay. All right, so with annuities, so this is the third of our recurrence relations. The thing that I find annoying with recurrence relations is they start to use different letters to represent the same thing. So we've just done a recurrence relation where the capital letter R represented an amount that we were paying off each month. Here we've got a little tiny letter D, and that actually represents an amount that we're regularly depositing. When we come to do our annuity formulas later on, you'll remember the formulas with the big capital M in them, and capital M and capital R are the same thing. So I'm not sure why they keep using different letters, but it makes it tricky when you've got to remember what all those things are. All right, so for this one, this is from your mock exam, so you've just done this last week. For this formula, so this is one when we have got, an annuity is something where you make a regular payment. So it probably won't say the word annuity in the question, but you recognise it as an annuity if you're making regular repayments. So regular repayments or you're paying off a loan. So something where you've just got a regular payment either coming out or going in, that's what an annuity is. All right, a young person has just opened a savings account, advertises an interest rate of 3.6 per annum. So in terms of highlighting, that's information we'll need, and we're compounding monthly. So that's important. So on the first day of each month, the person deposits $440. So 440, so there's a regular deposit going in, which tells us it's an annuity. Interest on the account balance is added on the last day of each month. All right, determine the balance of the account just after the 6th deposit is made. Okay. All right, so from here, so this value here, that is our little D value. So in that formula, the 440 is the deposit amount, so that's little d. We've got to work out the R value. Oh, I'll change colour. So our R value, which is 1 plus I. So our interest rate was 3.6% per annum. So again, you'll need to do your 3.6 over 100, so 0.036. Or you might do the 3.6, you might do 3.6 over 100 times 12 if you're doing the working that way. So you'll have 0.036 over 12, and that equals 1.003. So that's your R value for that rule. Setting it up as a recurrence relation, so the AN plus 1, RA to the N plus D, recurrence relation, we need the two components. So we need our starting amount. And because the person's just opened the savings account, there's nothing in there to start with. So it's a zero balance. AN plus 1, 1.0, oh, whoopsie, got a bit excited with the 3. 1.003 A to the N plus that payment of 440. So that's our rule for this scenario. Remembering that this rule works out term by term. Okay, so we've got to work out the balance just after the 6th deposit is made. All right, so in your calculator, we would type in 0 equals, then we'd do the times, so 0 equals times 1.003 plus 440. So that's what you would type into your calculator. And we're going to hit equals 6 times on that. When we hit equals the first time, that's then the balance at the end of that first payment. We need after the 6th deposit has been made, so we need A6. So equals. So we get our 2659.88 and we can put a dollar sign on there. Okay, so it's just making sure you count as you go. You might want to write down the numbers as you go as well, just to kind of help you to remember where you are. So that would be the balance just after the 6th deposit is made. Excellent question, Ron. And look, in the tips on the front page, we've actually said that you should do that. So probably you should not have been a little bit slack there. In the marking scheme, we have written them all down. Depends how many you've got to do, really. But because the thing is, that's just worth 1 mark. There's actually no marks allocated in this question for, you know, for writing the other values down. Would write them down as you go. From a marking point of view, this was only worth 2 marks, I think. So, and the other mark here was for mathematical reasoning. So if you had some sort of working that you'd shown there, we're going to give you a mark for that, and then you'll get a mark for that answer. All right, so that's one. Hopefully you remember doing that last week, maybe. Yeah, look at that, exciting. All right, the other one at the bottom of the page came from the mock from last year, so we're going to have a look at that one as well. And it's a multiple choice question. Okay. All right, so, and it's just looking at some different techniques for multiple choice. You were given, or they were given that graph, and then it just said to identify the recurrence relation that matches the graph. Okay, so looking at what they've written there, you can see all of them have the commonality of the A1 equals 50. And hopefully you can see that that value there, that's the 50. So all of them, we can't eliminate anything at the moment. From there, what I would do, or when I did this, I had a look at A2, and A2 looked like it was equal to 80. So reading that value there, that looks like it's on the line for 80. So I then kind of just used that value and tried out some of those different rules. So on my calculator, you could then type in, if we're checking this one, you would type in 0.6 times 80. Oh, sorry, 0.6 times 50, apologies. For the first one, times 50, which is your first value, plus 30, and we need that answer to be 80. So the first value was 50, the second value after that is 80, and if that equals 80, that's the rule. Only one of those will work, and what you'll find, the first one doesn't work, and you'll just go through and do that second one, 0.6 times 50 plus 50, and that did equal 80. So from a technique with multiple choice, sometimes you'll actually be able to work out the answer beforehand. Other times you'll just use the solutions or the options they've got there for you, and you'll just plug in some values and try and work them out. But certainly because a recurrence relation goes from one term to the next, using the second term or the second value from that graph means you can just sub in the 50 straight away. All right, so that's B was the option for that one. All right. Okay. Oh, bring on the annuities. We love these formulas. Oh, okay. All right. Righto. 2 different formulas on the formula sheet, and they are quite different. And these questions have appeared in all the past 3 papers, so external and the 2 mocks as well. So they're highly likely that they'll occur again. They tend to be in paper 2, which is the complex paper. So annuities tends to be complex. All right, with this first one, so we are going to go through this one on this page. With this formula though, so there's the one with the little negative sign on the power of the n, and this is our first one that we have. This formula we use if you have a zero balance to start with and you are making regular deposits into an account and you're building up to a figure at the end. That's what this is for. So this is a future value annuities calculation. You start with nothing, then you add regular payments in and you build up to something at the end. That's what this formula calculates. Sometimes you'll remember we've done questions where we combine this formula with the compound interest rule. And here we've just included those options there for you. So this would be a situation if you started with a lump sum. So you might have, say, $20,000. Then you make regular monthly repayments of $500, blah, 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 blah. How much do you have at the end of a time period? So if you start with a balance other than zero, you would need to have the compound interest formula added on to this annuities formula. In the second one, so this option here, we've used that quite a bit, and you might remember doing questions like that in class. I think we even had a question in IA2 on this, perhaps. Was it IA3? One of them. This is the one where you're paying off the loan. So you've got your lump sum that you start with, which is why we've got the compound interest formula. Then you are paying off a regular repayment over time. And the difference with those two formulas, of course, is the plus and the minus. So one of them's a plus, one of them's a minus. So the first one is you start with a lump sum, you keep adding money into that. The second one is you start with a lump sum and you are paying off money from that in a loan situation. Those formulas are not on the formula sheet. So the combination of those formulas, that's not part of the formula sheet. You would need to recognise when to combine those formulas. Okay, and that's a difficult thing to do. So these are complex questions, that's quite difficult. But this formula on its own, as I mentioned, is zero balance, nothing to start with, and you just make regular deposits. All right, so let's look at this question. This question was from the external exam last year. It was in paper 2, and question 7 means it was one of the last questions. All right, and you'll know that from doing the mock, they don't actually tell you whether it's complex familiar or complex unfamiliar. They just have all the questions in there. You can probably tell, though, from the questions that they have, and there's not many questions in there, so this was one of the last questions from last year. Okay. A couple saved for their retirement by making the same monthly payments. Righto, that information, regular monthly payments, means it's an annuity. So that is the actual definition of an annuity. So in that question, you would hopefully see that and go, oh, it's an annuity. I'm going to turn to those formulas. Or not, but hopefully you might. All right, so you've got 20 years into an account that earned 4.2% per annum, and we're compounding monthly. There's a lot of information just in that first sentence. At the age of 65, the couple retired and used all of their savings, so that could be important, all of their savings to purchase a perpetuity. You may remember there's an entire chapter, well, this chapter is actually called Annuities and Perpetuities. I think it's chapter 9 from memory. All right, the perpetuity formulas are not on the formula sheet, which is really annoying. Okay, so that perpetuity, we've got an interest rate of 5.76 and we're compounding monthly, and we've got another figure in there that's probably going to be important. So paying $3,600 each month. All right, so ultimately, how much did they save each month to prepare for their retirement? Whew, there's a lot going on there. And that might be something you had to read a couple of times before you get started. Okay, in terms of a perpetuity, so just to remind you, perpetuity means that if you've got an amount of money and it's going to earn some interest, you never actually, the balance stays the same as the principal. So the final amount that you have and the principal are always the same. So A equals P for a perpetuity scenario. In terms of the formulas in the book, so D equals I times P. So going back to that formula where the little d was the deposit amount or the amount of money going in, That's what D relates to. So this is our payment. I is the same as I usually is for us, and this is our principal amount. And we can rearrange that formula. So depending on what we're trying to find, that's the formula we would rearrange. I would just recommend that you remember that version of the formula, and then you can just rearrange it if you've got to find P or I. So that's the formula I would suggest that you recommend. So what we need to do though, we've got to work out what the principal amount was, because they were saving for their retirement, so they were making regular monthly payments for 20 years. Then when they got to the age of 65, so after that 20 years, they took that money, and then that money then paid them $3,600 a month, is what that's saying. So we've got to work out how much the savings was that they had. So what did it build up to in that time? All right, so our I value, so we're going for our 0.50. So this is for the perpetuity, sorry. So we're using our perpetuity formula, 0.0576, which is our 5.76 over 100. Again, you can do that other formula, do your 5.76 over 100 times 12. So that's 0.0048. So this is using our perpetuity formula with that information. The payment amount for that was $3,600, so we know that it's going to pay them that much every month. So we've got to find out what was the lump sum that they had that allowed them to do that. So how much money was in there that allowed them to pay that $3,600 a month? So if we rearrange that formula from over here, because we're trying to find the principal, that's going to be D divided by I. So we would just bring the I across to the other side. So our 3,600 divided by that interest rate, and that gives us 750,000. So that's their total savings that they had. So we know that before they purchased that perpetuity, or when they purchased it, that's how much the savings had built up to. So in the 20 years that they'd made those regular payments, it had built up to 750,000. And it also tells us that they used all of their savings. So we'd highlighted that earlier. It says they use all of their savings. So they are going to use all of that 750,000. All right, so that's the first part. We've got to find out how much they saved every month to prepare for retirement. So remember, for 20 years, every month they were putting money into the account. We now know that that figure built up to 750,000. So we've got to work out what that M value was back from our annuities formula. So from this formula, we now have the A value. We know A is 750,000. We're trying to find M. And we're using this formula because we were making regular deposits that was building up to a figure at the end. All right, so we have got, well, I fit it in here maybe. All right, so A equals M, 1 plus I to the N minus 1 over I. All right, so again, that could be worth marks just for recognising that it's the correct formula. And in fact, in this paper, that was worth 1 mark. For writing down that formula was worth a mark, which was very good. Okay, so things that we have from here. So we know that that's 750,000. We're trying to find what the monthly payment was. All right, this time though, the I value, sorry, I'll just go back to there. Because we're now dealing with this first section, our interest rate was 4.2% per annum. So I is going to be the 4.2%, so 0.042 over 12. So that's 4.2 over 100. That's that value. And that was possibly not very nice because I think I've left it as that in the formula. So you might want to check that. It might be a decimal. It doesn't actually terminate. All right, so putting that in, so we're going to use that. So for accuracy, I'm going to use that whole number. The N value we had, they did that for 20 years, I think. Yeah, so 20 years every month. So our N value is going to be 20 times 12, which is 240, hopefully. Is that a horrible number? Did anyone work that out? Is it hideous? Yeah. All right, we'll leave it as a fraction. It's not hideous, it's lovely. Oh, lovely. Let's put that in. All right, so what was that? 0.00. Beautiful, thank you. All right, and then N was 12 times 20, which I think is 240. All right, so they're the values we need this time. So we've used different interest rate previously. So putting that in, so we'll have 1 plus 0035 to the 240 minus 1 over that. All right, so 750,000 M times, and you might want to actually work out what that is. When you work that out though, even though you might write down a rounded off version of that on your page, you would still keep the full number in your calculator so that you would use your answer from the calculator to move that across. All right, now I got 375.13 something or other. Does that look good? All right, so again, leave that in your calculator. We just need to bring that across and divide it. So 1999.281, blah, blah, blah. All right, now this is, in terms of interpreting our answer, if we round that correctly, we would get 199.28. However, if we regularly deposited 1999.28, it wouldn't actually build up to the 750,000. So we would actually need to round that up to the 29. Even though mathematically we don't need to, but if we left it at the 28, it wouldn't reach the 750,000 that we need. All right. In saying that, 0.29 would take a little bit over, but it's better to be a little bit over than under. Okay, so sometimes in these questions, in terms of the monthly payment, you do need to round it up to the next value to make sure that you either pay off the loan or in this case, we build up to that value. Okay, and that's actually what we had to find, so that was the monthly savings. With these questions as well in the marking scheme, so this would be classed really, I think, as a complex unfamiliar question. It would have been one of the last questions. Often with the complex questions in the marking scheme, they allocate 1 mark for communication. So there's just a general mark at the end there if you've communicated or showed you're working, and this was certainly the case with this question. And there were other marks, I think I mentioned, even just for writing down that formula, that annuities formula was worth a mark. This was worth 6 marks, that question, all up. All right, in the breakdown you can see when I put the marking solutions or the guide into the drive, but there were 6 marks for that question. That's not easy. All right, just going back to there, as I said, perpetuities, not on the formula sheet, but that's the formula, that's the version I would remember. So just remember that one version and then you can rearrange if you need to. Okay, I'll put that back to there. Oh, that was intense. Oh, do you need a moment? Yes, right, okay. All right, so following on from there, there are a few other questions related to that formula. There's another one there that you can practice yourself. And then we move on to the other formula that we're familiar with annuities. All right, so we'll turn over. So you can do that one yourself. Then just move over to the page with the other formula that we're a little bit more familiar with, okay? Righto, do we need a stretching second? Righto, stretching.
Okay, guys, we're going to restart if that's okay because we only have 40 minutes left and we have a lot of stuff to get through. Sorry. I'm sure you're just as upset as we are. Ethan? Not upset at all. All right, guys, so we are going to restart now with the other annuities formula. We are trying to find a regular repayment. So if we have a look at this formula, it's a little bit different from the one we just did because it's got the minus at the front and it's got the minus n for the power. All right, so this is from the mock that you just did. Hopefully it looks familiar to some of you. One of the last questions. All right, so an electronics store advertises a TV for sale at a cash price of 3890. I'm going to highlight 3890. The store offers customers a no deposit reducible balance loan to buy the TV with 30 monthly repayments of $148.72. So I'm going to highlight that as well. The first repayment is due 1 month after the customer makes the purchase, just after interest for the month is added to the loan balance. So a customer decides to buy the TV using a similar reducible balance loan to the one that was offered by the store, but financed by their bank at an annual interest rate, and I'm going to do this in a different colour, of 11.76% over 24 months. How much does the customer save using the bank loan rather than the store loan? Assuming that usually the store want to make more money out of you. All right, so there's a few steps to this. This would have been a 6-mark question, 4-mark question, 6-mark question. All right, so the first thing that we're going to work out is how much they paid using the store loan. So we're going to go total repaid using the store loan. So we paid 30 repayments of $148.72. Which will give us $4,461.60. Okay, now we need to figure out the monthly repayment using the separate bank loan. And that's when we need to use this formula because we aren't given the monthly repayment. All right, so make sure when you're showing your working out, guys, you write what you're trying to find, because if you just do calculations all over the sheet and it doesn't make a lot of sense, then it's really hard for the marker. We get it because we see your work all the time. But if it's somebody that doesn't know you, they don't really care if you do well or not. You want to make sure they know what they're looking at. All right, so the first thing that we're going to do is write the rule out. And then we're going to pop in what we know. So we've been given how much we need to pay back. That was the first thing I highlighted. So we're paying back $3,890. We're trying to find that M, or that monthly repayment. So now we're just going to pop in what we know. I'm going to leave the interest rate as a percentage this time. So if you need to see it over here, we've got 0.1176 over 12. All right, so 1 minus we're going to the power of, so if we just go over here, we've got 24 months. All over. So it's a fairly comprehensive fraction that we've got now. Just want to move my brackets so you guys don't get confused, sorry. Okay, once you plug that in, and I'm probably not going to give you time to do that, but once you plug that in, we will get our M value multiplied by rounded 21.294. So we're just going to rearrange now and divide by the 21.294 to get our M value. So therefore M equals $182.69 using our bank loan. Okay, just going to go over to the side here and do it in a different colour. So now we're going to figure out how much we pay back using the bank loan. So total repaid using a bank loan. So we're paying this one for 24 months times 182.69, which gives us 4,384.56. So obviously the bank and the store are going to make a profit either way because they've made interest, but we want to pay back the smallest amount of interest. And then we're going to do our savings. So we're just going to subtract our two totals. Bless you. And we get a saving of $77.04. I'm just going to put a therefore statement at the bottom because it was such a big worded question and say the customer saved $77.04 using the bank loan. Even though that's not a huge amount of money, it's still worth saving. Okay guys, we're not going to do the next two examples. We're going to let you do that in your own time and then you can check the work solutions that Ms. Nardi will put up after our session. So if we can please flip over and we're going to go to sequences and start with arithmetic sequences. And we're going to go to the second example that was in last year's mock. Before we start that, let's just have a little look at the top of the page. So we've got our formula at the top of the page, but we've also got what everything stands for. So hopefully you can remember that when we do arithmetic sequences, we are just adding and subtracting each time. Okay, so Tn refers to the nth term. We also have to know T1, the first term, and we have to know little d this time stands for the common difference. So it's either a positive or a negative number. All right, so this is our sequence, and we need to identify whether the sequence is arithmetic or geometric. We can't just write the word, we actually need to prove why it is one or the other. And then we are going to determine the recursive rule for the sequence. So if you remember, Miss Nardi before was speaking about the recursive rule or the recurrence relation. So I'm just going to put a little arrow from there. Okay, so for part A, we actually need to show some proof. Even though it's very easy for us to see that it is going up by the same thing each time, you still need to show the marker that you know that. So to show our proof, we're just going to do some subtractions to show the difference. So if we do the first two terms, we can just do 23 take 19 equals 4. And I know that seems very easy, but please write it down. Assume your marker has no knowledge at all. So because we've got the same common difference, we're going to say therefore it's an arithmetic sequence. So as long as you show some proof there and you write what it is, then you'll get the full mark. So just as a side note here, if we were talking about a geometric sequence, which we're going to get to in a second, because geometric sequences are multiplication each time, the working that you would show, so I'm just going to write if geometric, then to show the difference, you would write, you do a division. So you do 23 over 19. Or you could do 31 over 27. That would show the ratio that you're going up by. But we'll get to that in a second, just so you know. Okay, so for part B, determine the recursive rule or the recurrence relation. So we know what the first term is. The first term is 19. We know that we are increasing, so we're going up by 4 each time. If we were going down, that would just be a negative 4. So we've written the first term. Now we're going to write our recursive rule. So Tn plus 1 equals Tn plus 4. That's all you need to write. Importantly though, this bit here, this is worth 1 mark and this is worth 1 mark. If you don't write the first term, then you don't get full marks for that. So if you need clarification on what an arithmetic sequence is or the recurrence relation is, I'm just going to write here, it is your rule to get from one term to the next. Remembering back to last year, this was a really poorly done question. We didn't do well on this question, so something to think about. Okay, guys, we are going to do another arithmetic sequence question. So let's skip the next one, which was on the paper that you just did. We're going to skip that one, and we're going to go to one of the questions on the external paper from last year. All right. So exhibition organisers believe that the number of attendees increases each day as an arithmetic sequence. The organisers know that 353 people attended on the first day and 439 people attended on the third day. So 2 pieces of information. So 353 on the first day, 439 on the third day. All right, so straight away, because we've been given the first term, we're determining the common difference, and then we're going to predict how many people will be there on the 6th day. So for A, we have been given T1, which is a great head start. We also know T3, so we're going to write that down as well. What we need to remember here is what our formula needs to look like. So we're going to go Tn equals T1 plus n minus 1d. Okay, from here we can just sub in the values that we've got. So we're going to use our third day, so we're going to sub in 439 here, equals our first term, which was 353, plus n minus 1. So if we're talking here, this 439 was the third term, so therefore in this instance, I'm just going to write in brackets here, n equals 3. If we have n minus 1, we're going to have 3 minus 1, or we're going to have 2d plus 2d. We're trying to find our D, so we're going to get rid of our, excuse my dyslexia for a moment while I change that number. So we need to get rid of that 353 to the other side so that we can just find our D value. So when we minus that across, we'll get 86 equals 2D. And then hopefully we know how to solve an equation, and we'll divide by 2, so we'll get a common difference of 43. All of that is worth 1 mark. Okay, so that's to find the common difference. We've done A. Let's go to B. So we're trying to find the 6th day, which is going to be T6. T6 equals T1 plus 6 minus 1D, because our n is 6. So let's simplify that. T6 equals T1 plus 5D. We have our D from part A, and we have our T1. Just want to point out to you guys here, if you end up doing something wrong in part A and you get the wrong D value, but you substitute it incorrectly here and get a value, then you're still going to get your marks for part B. All right, so we're going to have T1, which was 353, plus 5 times 43. So we're going to get a 6th day. They're thinking 568 people will attend. So this substitution bit here is worth 1 mark. So even with your wrong answer from part A, you can still get that correct if you've substituted it incorrectly. Any questions? Cool. All right, next we are going to geometric sequences. So there's another one there, guys, on arithmetic. We're not going to do it. We're going to leave it for you. Actually, there's another 2 there. Lucky you. Yep. Yep, absolutely. Okay, so for geometric sequences, there's 2 on that first page. Just note the different formula this time, guys. We don't have D this time, we have R. So R is our ratio. This is the number that we're multiplying by, or the value that we're multiplying by. So really important, on the left-hand side there in bold, people get confused with geometric sequences because it is always multiplication. It is never division. So if you have values that are decreasing, you are multiplying by a fraction. You're not dividing by a number. That's really important, because if you try and write your ratio as divided by 4, you're not going to get the right answer. You're not going to get any marks for that. All right, so we are going to go, we're not going to do that first page. That bottom one should look familiar because it was just in your mock. But you will be able to see those answers when Miss Nardi uploads, and she's going to do the next question.
Okay. We actually, from a time point of view, we're running out of time, which is really sad, and I'm sorry that we can't extend it for another hour or so to keep going. I know you're upset. Look, what we're going to do, I am just going to do one more question, not this one actually. I just want to do one on networks and matrices, which is then over the page. And then I've got a few general things to finish off with, because we want to make sure you get up to have lunch by 12 o'clock, those of you who are having lunch. And we'll talk about what we're going to do or for you guys to do beyond here. So just because networks, there aren't many formulas for networks, so apologies. So if you can turn to that next page, we'll just have a little look at this one. Networks, I think, covers either 2 or 3 chapters in the textbook. It's actually quite a big topic, but in terms of formulas, there's really not many formulas. There's lots of those definitions for you to know. But this is one using Euler's formula, and this was from the mock exam from last year. So just a couple of things with this formula. This formula works for connected graphs, so that means that all the little dots, all the little vertices are joined up. and they're for planar graphs. So a planar graph, you might remember, is that the edges are not crossing over. So this is a rule that works specifically for those with those two characteristics. In terms of the letters there, we've written them what they mean. So you've got vertices, faces and edges. So in this question from the mock from last year, you had to start off by sketching a planar graph that had 4 vertices and 6 edges. And that could have been any graph you liked as long as it fit those conditions. So if we just do one there. So I think I just went 1, 2, 3, 4. You might put an edge through there and then, I don't know, something there. All right, so there's 4 vertices. So the 1, 2, 3 and 4. And in terms of the edges that I've drawn 6 edges. Okay, and you could have lots of different variations on that graph. None of the edges are crossing over. So in terms of highlighting that with your question, you had to do a planar graph. And in your mind, you'd be thinking to yourself, oh, that means that there's no edges crossing over. And they told you how many vertices and edges to have. So in terms of using that formula, which is part B, we knew we had 4 vertices and we knew we had 6 edges. You just have to now count the faces in your graph. Now the faces are a little bit different. So faces in here, let me change colour. That would be one face, that little triangular section. That would be another one. That's another one. And the outside section is another one. And I think the definition is something like, the face is, I don't know, it's got an edge bordering it or something like that when you have a look at the definition in the textbook. But there's always one face that's out on the outside of the shape or the graph. So there are actually 4 faces there. So face equals 4. So using that rule, because it tells us in part B, we have to show that Euler's formula works. So that's just saying, sub in the numbers and show that they equal 2. So for our numbers, we've got 4 plus 4 minus 6. And 4 plus 4 is 8. 8 minus 6 is in fact 2. Yay, smiley face, go us, and we're done and we get the mark. Okay? And that's just an example of a question using that formula. That's from the mock from last year. There's another one down the bottom from your mock. So there was one in your mock that you did earlier in the multiple choice, and you had to use that rule, which you may remember. It's not really something that's come up a lot, and it's certainly only a simple simple concept even, can't speak. All right, look, it is, we haven't got a lot of time to go, and I want to give some general information. I know there's quite a few pages left in the booklet. If you're looking ahead in the booklet, there is some work on trigonometry, so the cosine rule and the sine rule, which is actually from Unit 2. So because the formulas are still in the formula booklet, it could come up as a question, which is why we've got questions in there. What we'll do, so Mrs. Simpson and I will make a separate video based on some of the other questions that we didn't get through, and we didn't get through to some of the stats work either, and there's a few things we want to highlight in the stats work at the end. So we will actually do a separate video and upload that into the drive, just as the video from today will be in there. So from here, as I mentioned, we've got all the work solutions in this booklet, and we've got extra information in there as well. So we've included the marking scheme, so where marks would be allocated. We've highlighted different things. We've got notes for that. So I will put that into the drive this afternoon. Just from a timing point of view, I'm actually running a session for the Maths Methods students from 1 till 3. So it'll be after 3 o'clock before I do this. Okay, so after 3 o'clock, I will upload the solutions and also an electronic copy of that booklet. Also, I've got another, I think at least 3 practice exam papers to put into the drive. So some of you will have done the ones that are in the drive already, and I've got more to put into there. So once I upload those with the solutions, I'll let you know, and I'll send an email to everybody to let you know that they're in there. In terms of your study from now, so these exams are on the 1st and 2nd of November. So it's in week 2 of the external timetable. We will have a session on the Sunday before the exam, which will just be, I think it's in the information Mrs. Scott has sent out. that'll just be sort of that final, the day before the exam, coming in with any questions you might have, anything you want to go over. That will be an opportunity to do that. I do want to remind you that on Monday mornings, there is tutoring on a Monday morning, so no Monday of week 1. That's a holiday, but certainly week 2 and week 3 at 7:30, might even start earlier, in T12, but I will send emails to remind everyone about that, and I'm hoping I might get a few people there. In terms of in class next term, so we'll only have, you'll have 2 weeks and I think 2 days of classes left. That's it, which is a little bit sad. What we'll be doing in class then, so we will, when we mark the mock exam, we'll be analysing that data and seeing if there's certain topics that we need to go over again. But certainly networks will be one of the big topics we'll be going over in class, and we'll be discussing with all the teachers what we'll be focusing on. Certainly there'll be a lot of focus on networks and other topics that come out of that mock exam. So the focus in your classes for the first your 2.5 weeks will be revising some of those bigger sections. Obviously that's not enough time to revise every single concept from units 3 and 4. With your revision from now, so if today is your first day of revision for the exam, well done, excellent. I would be planning it out from now until the 1st of November. So working out what you're going to do, when you're going to do it, and timing it that way. Can I put in a plug, and I'm not embarrassed to say this, this is a 50% exam on units 3 and 4. For some of you, this is your only 50% exam. For those of you who do sciences, you have others. In terms of the importance of this subject in relation to others, and I'm not embarrassed to say it, this is much more important than a 25% exam based on Unit 4 in terms of the time that you have to put into the study. So I don't mean maths is the most important subject, but the time that you've got to put into the study for this subject is significantly more time than you may have to put into one of those 25% just Unit 4 subjects. I only say that so that you factor that into your study. You need to be studying from this point until the 1st and 2nd of November. All right, so you do have to put in a fair bit of work for this exam because you've only banked 50% of your marks so far. What we found last year with the cohort from last year, mock exam results terrible. And look, as I said, to be honest, it's just a revision tool. We're not going to be overly worried how, if they're not great or great, whatever. However, there was a massive difference. So the cohort last year, their performance in the external exam was massively much better than what they'd done in the mocks. But they did an enormous amount of work between now and the external. So we were really happy. No one failed in the end. Everybody passed at the end. We were a little bit worried about a few, but everybody got through. But they did do, a lot of work between now and then. And you still have time to do that. So I would certainly encourage you to just put in, it's only a short space of time, put in as much work as you can. I mentioned at the start that practice exams are going to be probably one of the key things for you to do. So you should have, I think it's about 7 or 8 altogether, once I put the other ones in this afternoon. That's full exams on Unit 3 and 4 with all the worked solutions. So, and you might sort of do some now or, leave some till later or however you work that. Remember your textbook, there's a lot of revision chapters in the textbook as well. And I think there's one devoted, revision for Unit 3 and 4 together. There are chapters devoted just to Unit 3, just to Unit 4. So you've got more than enough to do in terms of revision. But it's just going to be a matter of sitting down and methodically working through it. Because for maths, as you know, the best way to revise is to do questions. So Monday morning sessions, a reminder that in the library on a Tuesday afternoon, there's maths help in the library. That's for an hour after school each day. I do a Wednesday afternoon from 3 till 4. That's something that I've always done for my classes, but I'm happy if you want to come along to that. And that's just to come and sit for an hour, and that's an hour of forced revision, and you can bring some questions along and ask that. So that's Wednesdays. And then, as I mentioned, the Sunday before the exam as well. Okay. Again, though, we really want to say thank you for being here. We appreciate it is your holiday, and you do need to have a little bit of a holiday. But we really are impressed with how many of you are here. It's nice to see that you are, keen to do some maths revision. So thank you so much for being here. look out for some emails from me this afternoon with those extra resources. And I think that's it from us. I think Mr. Scott needs to say a few words though.